is the quotient part, which is what we really want, right?
Yeah, okay.
So you also have the -1 because the, well, x equals to 1 and x equals to -1. So now I can just basically, well, in 4 intervals, -1 to negative infinity to -1, -1 to 0, I guess. Or -1 to, let me think, -1 to 0 and 0 to 1 and 1 to infinity, right? 4 intervals, right? Oh yeah, now this qualifies for this y. Y-axis is also asymptote. That's good. That is probably satisfies everything. And if you want to make more precise analyzations, and we should also conclude the near behavior about this part. So I can substitute x equals to -1. Well, which is just because I don't want this one to be all 0. So it's x plus 1 times -1 minus 1 over -1, right? So in the end, it's just
Sorry, I have a question.
Yeah.
For like, so like it's like for if the numerator is greater than the denominator, then it's y equals like the long division, right? And if it's equal, then it's coefficient, and if it's like the denominator is greater than the numerator, so it's y equals 0. Is that right?
Yeah. Well, which is this is the
Okay, yeah.
coefficient.
I just wanted to review, double check, because I think I got it wrong at first. I want to like review because it's been a while.
So this is something. This is you can take a screenshot, but this is a little difficult to remember, I guess, right? So in this part, you have to do the long division to get this. This is kind of easy when it's equal, right? When it's greater than 2 or equals to 2, then we can't really find it like asymptote. And for this one, it's just
Did it again.
Yeah, if it's less.
Not like on purpose, or I don't. Sorry.
Next thing, let's see. Oh, about the other one. So I can also say it's the same thing. So this one with 2x plus 1 would be behavior like this, right? It's a little almost straight line. And the same thing, and then here I can substitute all the way x equals to +1. So it'll be 1 plus 1 and x minus 1. I don't want to get this one 0, so it'll be 1. So in the end, it'll be just 2 times x minus 1. So that's the other thing part in here. How about this one? Example 3.
Y equals, oh, okay, hang on, let me write that down. Let me just graph it. Okay. And oh wait, but it's greater by, okay, if the numerator is greater than the denominator, then long division. No long division. Okay, no No asymptote.
Yeah. Oh, no horizontal oblique?
No horizontal asymptote.
No horizontal, no oblique.
No H/O. Okay, and then maybe I can try to find the y-intercept. Okay. Oh wait, never mind. Okay. Never mind. Scratch that. What about this? Okay, is that it? I think that's it. Yeah.
But we do have
I need to make some
y-axis.
stuff on the either side of like.
Yeah, y-axis is the asymptote, right? Is the vertical asymptote.
Yeah, I know. I just wrote that down. I'm just saying, I was just checking if that was it because I'm trying to remember if there's anything else for me to like do the steps of.
Sure. Although you can do long division, it can help you the shape. Because the cosine shape would be just like the new graph shape.
Okay, done.
Yeah, this is the thing. When you say no long division, you kind of forget that I say the quotient if I do division. So this would be x squared, right?
Oh yeah.
If it
Okay,
is
do we have
x
to
squared, it's the
Okay.
shape of that, right?
Okay, yeah, I forgot about that. Sorry. Okay, sorry. So there's that too. We have to do that. I thought there wasn't one. Why are you just saying this is fake now? Yeah, I thought that if it was greater than 2, then it just wouldn't be there. Why are you saying these things are fake now?
No, when I say not there, is no asymptote. It's not asymptote. I'm not saying there's asymptote. There
Okay,
is no asymptote.
then why do we need to notice if there's no asymptote?
Yeah, well, because the shape. How do you know that shape? You don't really know that
Pardon?
shape.
Pardon, what does
The shape of the graph should be looking like this.
Oh, okay, yeah. I did think I should probably look up. I did think that it was kind of weirdly symmetrical.
Yeah. Otherwise, if you want to
Okay.
do this, you have to do more. Wait, if it is y equals
How do
to
we wait, where's the vertex? Let me think. Where's the vertex of this thing? Oh, is it just regular? Ah. Okay, well, I'm just gonna say it looks like this. I can't figure out where the vertex is.
Well, I can try the easy number though. Can I? Negative
Oh,
1,
okay,
positive 1?
sure. Yeah, -1, +1.
And there is no x-intercept, right? Because y can't be 0, right? See, this cannot be 0. So y cannot be 0. You can't really get the exit. Does that make sense? So you can't really go down there. Otherwise, you have x-intercept. You have to find x-intercepts. So this one, there is no x-intercepts. No?
Okay, then it just doesn't do that. So what's the point?
So it'll be just looking something. If you have what you have right now, it's just, if you substitute positive 1 in there, 1, and that's so here 1, 2 in here. This is one other point here, right? That's another point, and they should look like y equals to x squared. What's y equals to x squared? This is y equals to x squared, right?
Yeah.
So around this, it should be looking like something here. And looking like something here. You can test it with the new value in there. Although I can't really draw anything in here, I can substitute 1. Saying I test -1 in here, I can test +1, and the next thing I probably should -0.5, right?
Okay.
It's -0.5 squared, I mean 4th power.
So
Plus
excuse me. So for this one, is it supposed to be for this one, is it supposed to be like I wrote, or is it supposed to be like, I don't know, like, or whatever?
No, you can't go in there. Probably have to go up. Otherwise, y-intercept, the y-axis can't be the asymptote
What do you
anymore.
mean? What do you mean go in there?
Yeah, for example, this x equals to 0 is the asymptote, right? It's vertical
Yeah.
asymptote, right? If you use the vertical asymptote, you can't really go in there. You have to go up. Otherwise, you have to reach
Okay.
down.
Okay, but I'm not okay. Well, but I'm asking about my graph. Is it like this, or is it like this?
Actually, none of them. What
Okay,
we
well,
draw is, we can be sure is in here. We can be sure it look like y equals x squared when x is infinity. It'll be something more like this, but we can't really be sure what's around here because this is small value, right? So in small value, you have to substitute. So for example, this one, and you see that
okay,
if I
no,
substitute
I know
0.
why, but why did mine turn out looking like this?
This is higher. It should go up.
You're not answering my question.
Hmm?
You're not answering my question. Why does this one look like this?
Which one? What is
This
the
one, the one I just circled.
wait? What is the function?
We have it right here. What are you talking about? I don't understand.
Wait, it's not this. Eventually, it looks like something like this. This is not the function here.
Okay, so this isn't, so it's not this function.
Yeah. So the function should
Okay.
eventually be looking like. Let me tell you, the function eventually should be looking like something like this. And it's a little bit symmetrical.
Oh my god.
In here. Let me in. It's not this. Why
Then
you
what
always ask me this? I'm not saying this is right. Does that make sense?
Yeah.
You're jumping the one because before we can connect it, but it get complicated. That's why we analyze this.
Yeah, okay.
Does it make sense?
All right, let me redo this on my own. So, okay.
Oh, you can use that dash line. Yeah. Y equals x squared. At least that you have that in your mind.
So now it's supposed to look like this.
Yeah.
Okay. Yeah, okay, yeah. I think I get it now. Sorry, it just felt weird because you were doing like a new like graph and stuff. I was trying it's just kind of confusing. So it's just kind of confusing sometimes when you switch a new thing and then I'm like they want something else and it feels
No, I'm
it
not
just
saying
it
your. It's okay. I'm not saying your graph is wrong, probably. So I'm just saying
you
that
you just said the graph was wrong.
yeah, yeah. So I'm just saying that there are some. If you are not certain about the new graph, not the one that we're familiar, that we have to throw in some points to check, right?
Okay, yeah.
And also that so the long division also something necessary, right? It'll give us y equals square. Yeah. It'll give us this, and also y cannot be 0 for this one, right? So you can't really reach to the x-axis, right? That's why you kind of have to go back in there. Otherwise, you will definitely go in there to cross that x-axis.
Okay, yeah. Sorry, just it sometimes it just goes like too fast where you like say things like in a way that's kind of like goes like a bit like long and like roundabout, I guess. So
No, okay. All right, how about this one? This new graph. For me, when I did this kind of, sometimes I throw in a lot of points in the beginning just to check.
oh oops.
Mm.
I was trying to
Ooh.
click eraser. Give me a sec. Okay, so
This is a little crazy graph. A lot of things to consider.
yeah, there's a lot happening.
Mm.
Okay, x equals 1. Sorry, this is taking a while. It's just like a lot.
No,
I
no,
have to
this is
like.
difficult. You should have seen that when great scientists before, they use a lot more time.
Wait, what did you say?
Actually, the scientists who actually study this, creatives who study this, they use a lot more time than we do. A lot of points to check.
Okay.
Yeah, great call about this part. Very nice.
Yep.
Yeah, this is in a normal case, this is almost perfect. But there's a slight trap in here,
Oh my God,
which
that's another
yeah,
trap. This
the
is
trap is that's why we normally check. We check a little bit. So this is your y equals to 3, right?
Yeah.
But at this part, we have to check
Oh my.
something. We have to check when x equals to infinite.
I can't hear you.
Yeah, negative infinity. So this part is okay. When I check because of 3 is okay, right? This is also okay. But it's very difficult to check this part.
Why?
Yeah, well, this is
I feel like I'm losing my mind.
yeah, this is something because you substitute let me so this is a 4, right? So because this is complicated, so let me substitute x equals to 5 and also x equals to 6 and also x equals to 7. So that's the crazy thing about this.
Why are we substituting so much? I already have a bunch of work done.
Yeah,
out
because
there,
this
right?
thing in here, so eventually you can see that because you can't really know that
Wait, it
for
goes
sure.
under there? Why? Oh
Yeah,
my
yeah, that's
God.
it. See,
Suck.
let's go to well, if you
Why does
substitute.
the asymptote only work sometimes? What's the point of having it at all if it only works sometimes? This is crazy.
Yeah, that's why in the old time they just basically have like a 30 or 40 more points to check. So they don't totally rely on asymptote. We rely on asymptote too much.
Okay,
That's
well,
why.
well, I don't really care about the old times. Why did you explain to me right now why the asymptote sometimes doesn't work?
Well, asymptote only works sometimes. Asymptote means well, this works out in here, so you can't really blame them. This works out in here perfectly, but it doesn't say it works out in here. So that's why we have to throw in some points to check. So when you throw in x
But
equals to
why?
7,
But why does it only work sometimes? Why doesn't it work all the
well,
time? I know I
well,
already asked you this. Sorry, I'm just having trouble understanding. Sometimes you just like talk like for a really long time and
no, I'm just saying asymptote never promised us they can just solve the entire.
okay.
Which means it's just a
Yeah, I
part. Have
get
you
it.
heard
Yeah,
like
okay.
have you heard like a called local maximum or local minimum? Have you heard that before? No?
Local maximum,
And
local
local
minimum.
minimum, which means
I've heard
it's
of maximum minimum, but like
Yeah, so
what does the local bit mean again? I think I've heard of it, but I don't know.
yeah, local, which just means if I use the oblique asymptote, it's something like this. You see, it's the asymptote, sure, it's in here, but it doesn't stop. In here, they cross. What can you do? Does that make sense? So can you say it's not asymptote? It is asymptote in here, but it's not asymptote in the other part.
It's just not asymptote for sometimes for no reason.
Yes, not for no reason. It because you only check a lot of numbers, so you say this is the asymptote in here. The other part you don't check, you can't really know. Does that make sense?
Not really.
Which means you only check. You have to use a lot of numbers saying this is the asymptote.
You have to check everything.
Yeah, in the beginning, yes, we have to check.
In the beginning, but now what do we do?
No, now we still have to check. So that's why we do this analyze.
Then why was it? So why are we saying in the beginning? Okay, whatever, it's fine.
Yeah, well, that's why some people still prefer it's point by point, and then you can get the pattern for sure. Otherwise, sometimes working, sometimes not working. So in this one, you substitute x equals to 7. That's why you check with the graphing calculator in the end. That happens a lot. But you also have to know how we did there. X equals to 7. This is the thing about math. Sometimes you have patterns, sometimes you don't have the pattern. You just have to accumulate.
Yeah, okay, that kind of makes sense, yeah.
So when x equals to 7, that's a little crazy. Let me substitute x equals to 7. 3, 7 squared minus 21 over 3 squared. 9 plus 3 minus, I'm not, plus 7. Wait, let me use 7. Yeah, 7. So this is 49. And minus 12. And that's do you have a calculator? Can you do this? This is the thing. This is a number below 3.
37 to the power of 2. I have my phone. I can do it on there, I guess. 37 to the power of 2. It's 37, right? No variables. Minus 21. Give me a second. I'm putting parentheses around everything and like 48. I can't read that very well.
Yeah, 49 because that's
49
plus 7 minus 12. Plus 7 minus 12.
Okay. It's like 30.636363636.
Anyway, and remember it's a little bit less than 7, less than 3, right? Is it? It's 2 point something, right?
I'm confused. We have 37 to the power of 2 minus 21 over 48 plus 7 minus 12, right? Or can I just not read your handwriting?
Yeah. So you just substitute, or you can, let me just type with my calculator.
Wait, what do you mean substitute? This is 30.
I'm substituting x equals to 7 to this function to make sure when x equals to 7 is actually below 3.
You mean 3 times 7? You mean 3 times 7?
Yeah, 3 times
So I thought it was 37.
Squared.
I thought it was 37. You have a very confusing graph. You have a very confusing handwriting. Sorry.
Yeah, I guess.
It's 2.86.
Yes. So it's a little bit true, right? A little bit below 2, which means it's crazy. When you substitute x equals to, yeah, it's below 3. When you substitute x equals to 6, it's actually 3. So that's why we have to find that. So this is 6, 3, and the other one is dropping. So how can this? But if you keep the infinite in, if you keep infinity in, it's still 3, which means it drops a little and eventually it goes back.
Yeah, that makes sense. Sometimes it just doesn't work for some reason.
Yeah. So that's why the easy point is just to basically try everything. Does that make sense? Then you try everything, and in some portion you have a pattern, and you'll be happy with it. Does that make sense? That's why science, in a lot of time, when we collect a lot of data and there's no pattern, it's also true. Is that making sense now? So the left part is okay. You're right. This is getting more and more complicated, so sometimes you can feel that SC node is not working. So in this part, it drop a little bit and it go back. Eventually, it's like this. Does that make sense a little?
Yeah.
Yeah. Okay, let me clear everything. Wait, where is it? So that's why you kind of have to do this anyway, and that's not enough. See, that's if you do all this, you still can't really find it. So when you actually do it, you find more points in here. You try to make sure your pattern is right. You ever get ready? Does
Yeah.
that make sense?
Yeah, it makes sense. Sometimes you need to check it sometimes. If it doesn't work,
Yeah.
yay. If it
Yeah.
works with yay, then if it doesn't, well, it just doesn't. I guess I don't know.
Yeah, you just consider it's in the stalking market. It's just the one that you have. Yeah, it goes up and down. You can be only finding pattern in a very short period, and then you have to change the model. It's a little difficult to tell even in the graphing calculator. See, this is a graphing calculator thing. It couldn't tell. You just have to try out a number there. Otherwise, it's not making sense. Here, how about this one?
Oh, okay. Give me a second.
This one won't be that crazy. The one we just did is the
Okay. I don't know if I have any space on here. Can you zoom out so I have some space to write the graph? Thanks. And scroll down. Scroll down. I can't see it.
Yeah.
Oh, okay. Never mind. This is fine. Okay, x equals -2, easy, and y equals 2. Oh, this is so easy.
Yeah. Be always like that, otherwise we get crazy.
One over 3. Okay. And 0, 2. Okay, let me y. 18 minus 15. 3 plus 2, 5. 5 over 5. Okay, 1.
X equals to 2 is not asymptote.
Oh, okay. Why did you wait so long to say this? Why wouldn't it be an asymptote?
It's just
if we substitute
because
it in for the denominator, then
there
2
is a
minus
factor.
4
You can
equals...
factorize the denominator. There is an x minus 2 term, so you can't. That will make that one 0.
Yeah, I just said it was an asymptote. What are you talking about?
Well, wait. This is Can you
What are you
factorize the?
talking?
Can you factor the numerator?
I factorized it. What are you talking about?
That's denominator. I said.
What are you talking about?
I said numerator.
The numerator? What does the numerator have to do with anything?
Remember with the number 4, the one of the number 4 that we did?
No.
The one, let me go back to that. There's one that you have to give up.
I have to give up? What do you mean?
Yeah, sometimes you have to, well, all the time, but the other time doesn't really use that. I remember this one. Now where's that one? Yes. It is x plus 3 and x minus 3 here, right?
Yeah.
And then you have x minus 7. Wait, x plus 7 should be.
Oh, yeah, I remember now. I remember. Yeah.
And this one
so
is
if it shares the factor, yeah.
yeah.
The factor.
This one is a brother for that one too.
Sorry, I didn't think. Sorry, I wasn't thinking about that. Sorry, it's just been a while.
Yeah. Yeah, this part is always the part that people get crazy.
X minus 4, x minus 1. Oh yes. Okay, so it's just x minus 1 over. Oh wait, it's not. Does this count? No, it's x. No, wait. It's still, if it's x. If it's like this, then I don't think it can be.
Wait. That's not the factorization. If that's the case, that'd be good for us. It's x minus, well, since I already said x minus 2, let's try that one. And the other one would be 2x. How do I get the 5? Let's try minus 1, minus 2. Yes, this is minus 5. So this is the one. Your factorization is...
Okay.
But this one will be... You can't really have... Yeah, there's a 2.
I don't understand how you found 2 out of that, to be honest. Oh wait.
We have a way.
Yeah,
you probably didn't really use
the rules are different from. Okay, fine. Whatever. Okay, so this is now sudden. Oh, sorry. Okay, let me just erase this for a second. Okay, so now it's just. So now I guess it's just So I guess it just pens off like this into the distance forever. Then.
Yeah. It'll be something like this. And also, sadly, because x cannot be true, so there is going to be a hole in here, right? Like this. So one of the points you can't really include, right?
Okay. I can't really draw a hole in there. Okay.
Yeah, you don't have to. I mean, this is drawing that.
Okay. Yeah, and why can't it be true again? Let me think about this.
Because you substitute x equals to 2, y is, the denominator is 0.
Well, yes, it is. Oh, don't you mean here? Don't you mean Sorry, that's 3. That's x equals 3. What are you talking about?
Oh, that's 3? Oh, here.
Yeah, here.
Yeah, okay, sure.
I just was confused because you were pointing at x equals 3.
Yeah.
So I was like, okay, why is that a hole? What does that have to do with anything?
Oh, I thought you don't really have the scale or anything.
What are you talking? What? I don't
No,
really
you have the scale.
what?
I just don't
the
assume.
scale.
Yeah, I don't use scale. I
Oh,
didn't
the
use the scale.
scale. Okay.
Yeah,
I thought you said scale, and I was like, what does it have to do with being scaled?
yeah. You do according to that.
Okay, give me a second to check the negative bit.
Yeah.
Okay, let me just get rid of that. Seven. Okay. 3, 4, 5, 6. Okay, yeah, I got it.
Yeah, that's the one.
This is excellent.
So let's see the homework. Wait, is it the time? Yeah. And
Oh, it's time.
so now we have to respect the graphing calculator a little bit more, right? And also the Google in what? The Google Maps. See, when they can draw something, they know, but it's difficult for us to draw. They have to give a function or something. So how much time do you have for homework for the weekend? How long you have? Ooh, Isabel?
Yeah, I have to go to give me a second. I keep muting back. Okay, I have to go to 3-hour art class every day, and I'm doing a house class over the summer, and I'm also getting ready for computer science next year. So there's like just a lot of things going on. And I have to do homework for the art class too, which sucks because it's every day. So then I have to like be like, oh, well, I have to do the yeah. I'm working on the Scholastic. I'm trying to go to the Scholastic art and writing competition, which is like really hard and stuff. So I need to get it done, and I need to get a lot of submissions in. I need to get a lot of pieces done for that. So I have to go to class go to the class for 3 hours every day, and I have to do homework.
Sounds like you have a very dedicated summer break. Let's say this is page. Let me see which page. 211.
Maybe 2 hours. I should be generous. Like this weekend or whatever.
Yeah, from 15 to
Wait, page what?
211.
211.
From 15 to 36.
Okay, that's it.
Yeah, and also 34 and 43 and 44.
43 and 44.
Yeah, and also a little bit previous one. Let me see. This is
Is it
page
15 through 36 or is it 15 and 36?
No, true, not and true.
Through.
Yeah.
Okay.
Yeah.
Understood.
And 198, page 198.
And page 190, all of it?
No, 40, 45
45?
to 53.
Okay, is that it?
Yeah.
Okay, yeah, I got okay.
Estimate is easier, but the analyzing, oh, that's crazy.
All right, yeah, bye. Thank you.
Bless you.